Hello, I hope you are doing well. Today, we will implement a face recognition system using convolutional neural network. Instead of building everything from scratch, we are going to use GoogleNet, a very popular convolutional neural network. It has been trained with thousands of images and it can classify 1,000 different objects. We are going to apply the concept of transfer learning to replace the last layers of GoogleNet with our self-defined layer so that we can train it to do what we want it to do. And what we want is to train it so that it can recognize human faces. It is going to be a very interesting lesson. Let's get started. This lesson is divided into 3 steps. The first step is preparing the dataset. The second step is training the network. And the third step is testing the network. To keep everything organized, create a folder on the desktop or wherever you want. Name it GoogleNet CNN Face Recognition. Then go inside of this folder and create another folder. Name it my_dataset. Now we are going to prepare the dataset and store it in this folder. Open your browser and search for some facial photos. Let's pick up photos of some famous people. Search for Tom Cruise. Then go to images. Click on any of these images. I'm going to use snipping tool to snip images from here. Click on this new, then snip the image. Click on this save button. Locate the My Database folder, which is located in our working directory. Create a folder here and name it Tom Cruise. And save the image inside this folder. Name it Tom_1. Save it in JPG format. Now go to the next image by clicking on this arrow symbol. Snip it and save it. This time we are saving it as Tom_2.jpg. In this way, collect 8 more images. Go to the My Dataset folder that get inside the Tom Cruise folder. Here is the first set of images of our training data. We need more dataset like this. This time, we're going to create a dataset using Elon Musk's images. Create a folder and name it Elon Musk. Then go to the web browser and search for Elon Musk. Click on this images, then choose any of the images here. Again, use the snipping tool and snip the image. This time, save it inside the Elon Musk folder and name it Elon_1 and save it as JPG. We need 9 more images like this. Click on this arrow button to get the next image. Again, use the same method to snip these images. Save it as elon2.jpg. Do the same thing for rest of the images. The dataset of Elon mask is completed. Let's go to our dataset and see the images. Here is the dataset for the facial image of Elon mask. Go back to the My Dataset folder and create another folder. This time we are going to collect the photos of Stephen Hawking. Go to the web browser and search for Stephen Hawking. Go to the image, pick up any of this image you want, and again use the snipping tool to snip the image. Save it inside the Stephen Hawking folder and name it Stephen_1 and save it as JPG. For the next image, click on this arrow button and again use the same method to snip the image, and this time save it as Stephen_2.jpg. In the same way, collect 8 more images. The dataset for Stephen Hawking is ready. Now go back to My Dataset folder and create another folder. This time we are going to create the dataset using Einstein's images. So write Einstein here. Now go back to the browser and search for Einstein. Click on the images and pick any of the images. Then using the same method, using the snipping tool, snip the image, save it in the Einstein folder. This time the name will be Einstein_1 and save it as JPG. In the same way, collect 9 more images of Einstein. Our dataset is ready. Launch your MATLAB. Then click on this Browse for Folder icon. Locate GoogleNet CNN Face Recognition folder and select this folder. We are now inside of our working directory, and here is our dataset. Now click on this plus symbol to create a new script. Save it as training. The first task is to load the dataset. We use image data store to load and organize image dataset in MATLAB. The first argument of image data store is the location of the dataset. Our dataset is located in the working directory. Therefore, write the name of the dataset folder. We organize the dataset in subfolders. That is why we have to include the subfolders. We do it using include subfolders properties. Then we set the value to true. We are going to perform face recognition. Whenever a face is recognized, we want to show the appropriate label of that image. For example, if Einstein's photo is recognized, then the label of the image will be Einstein. That means the label source of our program are the folder names. Let's store the entire dataset in a variable named dataset. Now we have to split the dataset into training and validation dataset. We use split each label function to do it. The first argument of this function is the dataset we want to split. In our code, this is the dataset. We want to split the dataset into 70-30 ratio. It means 70% of the data will be used as training dataset and rest of the 30% dataset will be used as validation dataset. Now we are going to load the network. We have learned how to load the network in the last lessons. That is why I'm not explaining it again. Simply write GoogleNet and store it in a variable named net. As we are going to modify this network, we need to have some idea about the structure of the network. We can visualize the structure of the network using analyze network function. It requires the network as the argument. Our network is stored in this net variable. So paste the net variable here. Let's run the code and observe the network. This is the network. The name of the first layer is data. And the input type is image. That means this network accepts images as input. However, the size of the input image has to be 224 by 224 pixel. And it has to be a 3-channel image, for example, an RGB image. It has 144 layers. I want you to observe the layer number 142. The name of this layer is Loss Tree Classifier. It is a fully connected layer. It has 1000 activation nodes. Actually, this is the layer which has been trained to recognize 1000 different objects. We will replace this layer with our own layer. Then we will train that new layer with our dataset to recognize faces. Now observe the last layer. The name of this layer is output, and it is a classification output layer. That means the recognized images will be assigned to different classes through this layer. We have to modify this layer as well. Now go back to the script. Then go to the command window, clear everything here, then type net.layers1 and hit enter. It shows the information about layer 1. We want to extract the input size. So type net.layers1 again. We have seen that by this code, we can access the network information of the first layer. We want to access the input size. So type dot, then write input size, then hit enter. Now we have the input size only. We will need this information during the training process. So copy this line and paste it here. Then store it in a variable named input layer size. We need to extract the entire architecture of the network. We use layer graph function to do that. And this function requires the network as input argument. And it returns the architecture of the network. Let's store the architecture of the network in a variable named layer graph. We have already learned that we need to replace the 142nd and 144th layers. This layer is responsible for learning task-specific features. For example, if we want to train our network to recognize a car, this layer learns the features of a car. Let's take a variable named feature learner and store 142nd layer in it. First, we write the name of the network, which is net, and then we add a dot here to access the network. Then type layers, then write the layer number you want to access. So with this line, we are entering into the network and copying whatever we have in layer 42 and storing it in the variable named feature learner. Then take another variable, this time name the variable output classifier, and follow the same approach to access and copy whatever we have in layer 44. We need one more information before starting defining our own layers and replacing the existing layers with them. That is the number of classes we need. The number of classes is the number of categories we have in our dataset. We have 4 different categories in our dataset. That means the number of classes is 4. We calculate it using a function named numl. It finds out the number of elements. As a matter of fact, the numl is the short form of number of elements. We want to find the number of elements of categories of training datasets labels. Let's store what this function returns in a variable named number of classes. Now we are going to define a fully connected layer, which will replace the 142nd layer of the GoogleNet. Notice carefully, the type of the layer is fully connected. We can create a fully connected layer using fully connected layer function. The first argument of this function is the number of classes. Now we will assign a name to our new layer. Use the name property. The value of this property is the name of our fully connected layer. Let's call it facial feature learner. Or you can use any other name. I'm breaking the code into a new line so that it becomes easier for you to read. When we use these 3 dots, MATLAB considers the following line as the part of the existing line. If we do not use them, then MATLAB will consider it as some new statement. Now we have to define the learning rate of the new layer. The name of the property to do it is weight learn rate factor, and the value is 10. This is not the actual learning rate. This is a weighted learning rate. Again, going to a new line. The next property is bias learn rate factor, and the value is 10. Again, this is not the actual value. This is a weighted value of the bias. So we have defined a brand new fully connected layer. Let's store it in a variable named new feature learner. We have to define the classification layer too. we use classification layer function to do that. The name of our new classification layer will be face classifier, or you can use any other name, it's totally up to you. Let's store this new classification layer in a function named new classifier layer. So we have defined two layers. Now it is time to replace the existing layers with our self-defined layers. The function we use to do it is replace layer. The first argument of this function is the architecture of the network. We stored the architecture of the network in this layer graph variable. Copy the name of this variable and paste it here as the first argument. Then we need to tell this function the name of the layer we want to replace. We have already stored the 142nd layer in this feature learner variable. So copy this name, paste it here, and we want the name property. So write dot name. Now this feature learner dot name will give us the name of the layer we want to replace. The last argument is the layer we define. That is the new feature learner variable. So copy the name of the variable and paste it here. Now this function will replace the existing fully connected layer with our newly defined layer. Let's store it in the layer graph variable. Now in the same way, we have to replace the output classifier layer with the classification layer we have defined. So copy the entire line and paste it here. This time we want to know the name of the output classifier. So change this feature learner to output classifier. And we want to replace the output classifier layer with our new classifier layer. And finally, the change is stored in the layer graph variable where the network architecture is. Now use analyze network function and analyze the layer graph. Let's run the code. Then observe the 142nd layer. This time the name of this layer is facial feature learner and it has 4 output classes. Then look at 144th layer. The name has changed. It is now face classifier. So our network has been modified. Now we can train it with our dataset to recognize Elon Musk, Stephen Hawking, Tom Cruise, or Einstein. However, before training the network, we should modify the images a little. This modification will prevent the training process from overfitting. We use image data augmenter to perform the modification. However, before using the function, we should define the range over which we want to modify the images. Take a variable named pixel range. The range is from -30 to 30. Take another variable named scale range, and the range is from 0.9 to 1.1. Now we can use the image data augmenter function. At first, we have to set the randx reflection parameter to true so that our modification is reflected along x-axis. Then use randx translation parameter to translate the image along x-axis using the pixel range we defined here. It is becoming a lengthy line. Let's go to the next line. Then use rand-y translation parameter to translate the image along y-axis using the same pixel range. After that, use randx scale parameter to scale the image along x-axis, and the range of scaling has been defined here. Then use the rand-y scale parameter to scale the image along y-axis and use the same scaling range. Now this function will randomly shift the pixels and scale the images. Let's store it in a variable named image_augmenter. I'm organizing the arguments into new lines so that it becomes easier for you to read. So we have defined how the image will be modified. Now take an augmented image data store. We have seen that the input layer of our network requires 224 by 224 pixel image. That is why we need to resize every image before transmitting it to the network. The first argument of augmented image data store is the size we want our image to resize into. The size has been defined in input layer size variable. Paste it here as the first argument. However, it includes this channel information as well, so limit it by adding 1:2. Now it contains the image size only. The second argument is source of the image. It is our training dataset. Paste it here. Let's go to a new line. Take the data augmentation parameter, and we have already defined how our image will be augmented in image_augmenter. Copy it and paste it here. Then store everything in a variable named augmented training image. We need to change the size of validation images too. Copy this entire line and paste it here. Remove this part. Here is our validation dataset. Copy it and paste it here. Finally, store it in a variable named augmented validation image. So our image modification is completed. Now we can proceed to the training process. We are going to use mini-batch method. The size of mini-batch is 5. Now we need to specify the validation frequency. To calculate the validation frequency, find out the number of elements we have in augmented training image files, then divide it with the size of mini-batch. It may return a fraction. However, the validation frequency has to be an integer. So use the floor function to round up the decimal points. Now this line will return the validation frequency. Store it in a variable named validation frequency. Now we need to specify the training options. There is a function named training options. We can use it to do it. We're going to use stochastic gradient descent with momentum to minimize the cost function. Write SGDM here which is the short form of stochastic gradient descent with momentum. Then break into a new line. The mini batch size will be this value. Break into another new line. The maximum epochs will be 6 for this example. Go to another new line. The initial learning rate for this example is 3 into 10 to the power inverse 4. We write 3 into 10 to the power inverse 4 in MATLAB like this. Go to a new line. We want to shuffle in every epoch. Now we have to specify the validation data. Our validation data is stored in augmented validation image variable. Paste it here. Then go to another new line. This time we are setting the validation frequency, which is stored in validation frequency variable. Go to another new line. We don't need any verbose in this example, so use false here. And we want to plot the training progress. These are our training options. Let's store them in a variable named training options. Now we can start the training. We use train network function to train a network. Then we supply the training images. Our training images are in augmented training image variable. Then we need to supply the network architecture to the function. The network architecture is stored in layer graph variable. Finally, we need to provide the training options. We have specified the training options in training options variable. Now this function will train the network and will return the trained network. Let's store the trained network in net variable. Let's run the program. If we have not made any mistake, then the training process will start. Let's run the program. If we have not made any mistake, then the training process will start. This is the architecture of the actual GoogleNet. And this is our modified network. The training process has started. The accuracy is low and the loss is high at the beginning. However, the accuracy will increase and the loss will decrease eventually. We can see the accuracy is increasing and the loss is decreasing. Now the accuracy is close to 100 and the loss is close to 0. The training process is completed. The validation accuracy is 81.82%. It is good enough to recognize faces. It is time to test the network. Close this window, close the network analyzer, launch your web browser. Then search for a photo of Einstein. Go to the images and save any of the pictures. Let's take this one. Save it in the working directory. and name it image 1. Now search for Stephen Hawking and pick up any of the images you want. Let's take this one. Save it in the working directory as image 2. Now go back to your MATLAB script. You'll see the image 1 and image 2 are here. Now we can test the network. Click on this plus symbol and create a function and name it test_network. This function will require the network and the input image. At the very beginning, this function will read the image. Then we need to resize this image so that we can transmit it to the network. We use imResize function to resize the image. The first argument is going to be the image we want to resize, and the second argument is the resized size. We want to resize the image to 224 pixel. Let's store the resized image in a variable named g. Now we will use classify function to transfer this image to our network, which is net. And this classify function will return two values. They are the label of the image and the probability of the prediction. Then you use the figure object, then use imShow function to show this resized image, and on top of the image we will show the label and probability using the title function. And this is the end of the function. Save it as testnetwork.m. Now in the command window, type the name of the function, that is test network. The first argument is the network we trained, and the second argument is the name of the image. We want to test image1.jpg. Our system has predicted him as Einstein, and the accuracy is 98%. Let's see the performance of our network for the second image. Our network could recognize Stephen Hawking with 88% accuracy. So this is how you can train a convolutional neural network to recognize human faces. I showed the procedure using facial images. It doesn't mean that it works for facial images only. You can train your network to recognize different objects or classify medical images. As long as there are distinguishable features, this procedure will work. However, sometimes you may need to enhance the features. You can use image processing algorithms to do that. If you need any help regarding to image processing and machine learning, you can leave a comment here, or you can communicate with me at faruqijaman27@gmail.com. And one more thing, don't forget to subscribe.